We're going to look at some more problems that we've done in the first semester. This particular problem is using order of operations. When we're asked to evaluate this expression and find the value of it, we want to think that there is an order to this operations. We call it please excuse my dear Aunt Sally. Now as I think about the PEMDAS, I need to think about other things that go with it. The P is representing anything that is inside the parentheses. The E is like an exponent. It, for an example, if it's 2 to the third power, it actually means to multiply 2 times 2 times 2, which would be not 6, but 2 times 2 is 4, times 2, which is the value of 8. I also need to consider that multiply, divide go hand in hand. They're inverse operations, so it's whichever one comes first as you read it from left to right. The same with add and subtract are inverse operations, so it's whichever one you read first, reading from left to right. So we're going to try and work this problem. Remember, you want to work one step at a time. Do I have parentheses? That answer is yes, so I want to look inside the parenthesis and only do that one small part of the problem. 10 minus 3, and we're going to answer it as 7. Everything else comes on down, and we just rewrite it. We bring down the add sign and the 5. We bring down the multiply sign and the 2. Now I have a new, simpler problem. I'm going to go through my list over here. Please excuse my dear Aunt Sally. Parentheses, there are no more. Do I have any exponents? No, I don't. So now I'm going to multiply, divide. Do I have any multiply, divide? And I'm going to read from left to right, and I come to a multiply. So I'm going to underline this process and answer it. 2 times 7, which is 14. And then as I'm finished with that, I'm going to bring down whatever part of the problem is left. As I'm doing this, I'm making a simpler problem and going through my steps again. Please excuse my dear Aunt Sally. I have finished with the parentheses, finished with the exponents, multiply, divide. Do I have any more? No. Let's move on to add and subtract, and it is add. And when I add these two together, I get 19. This is my final answer, so I can match it up to my answer over here, 19. You must follow this step in this process of order of operations from the top to the bottom, repeating the step each time you go. Now let's take a look at another problem that seems to be highly missed, and this is prime factorization. When I read the words prime factorization, I want things to go off in your head. The word prime, when I think of the word prime, I'm actually thinking of numbers like 2, 3, 5, 7, 11, lucky number 13, 17, 19, and the list will go on. These are prime numbers, numbers that have only divisible numbers by 1 in itself. And then factorization just means that we're breaking this number down. Now you can approach this problem several different ways. You can try each and every problem to see if you can get 360. You can take 360 and break it down yourself. Or my first step that I like to consider is just looking for numbers that are prime. And this is a really good test-taking strategy, because if a number is not prime, then it cannot be the prime factorization. For example, 180 is not prime because it ends in a 0 and it's divisible by 10. 9 is not prime because it's divisible by 3. 30 is not prime because it's divisible by 10. D has prime numbers, but we do want to test it out, and this is where we can practice using those exponents. If I have 2 to the third power, it is equal to 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. And then I'm going to go do the next part of the problem, which is 3 to the second power, which is equal to 3 times 3, and 3 times 3 is 9. Now it's telling me to multiply these two numbers together, so I'm going to multiply 8 times 9, and I'm going to get 72. and then it tells me to multiply by 5, so I'm using part of my order of operations to figure this out. This is not a math fact that I can do in my head, but I can come over here to the side and say 72 times 5. 2 times 5 is 10, carry the 1, and 5 times 7 is 35, plus 1 more, which is 36, and I've just met my target for prime factorization of 36. This is only one strategy to work this problem. There are several, but I would consider that you look for prime numbers first before you move on. This last concept that we're going to talk about right now is greatest common factor. When I read this problem right here, I see the word greatest common factor. I need to remember that what greatest common factor is asking me to do. Greatest common factor means factors. And here I have 3 numbers. I have number 24, 18, and 12. When I think of factors, I'm thinking of math facts for 24. I'm thinking of math facts for 18, and I'm thinking of math facts for the number 12. So I'm going to start with 1. Of course, every number is divisible by 1 by multiplying it by itself, which is 24. 2 times 12, 3 times 8, and 4 times 6. Can I multiply 5 times anything? And then my 6 is on the other side, which tells me I'm probably finished. Do 18 the same way. 1 times 18, 2 times 9, 3 times 6. Can I multiply 4 by anything? No. 5 by anything? No. 6, and I move to the other side, so I should be finished. 1 times 12, 2 times 6, 3 times 4. Ooh, consecutive. Went all the way over to the 4, so I'm finished. So now I'm looking for the greatest number they have in common. They have a 1, they both have a 2, or all 3 of them have a 2. They all have a 3, a 4, and a 4, but this one does not have a 4, so I cannot pick 4. I have a 6, and a 6, and a 6. We have a 12 on either end, but this number does not have 12. We have 9 and 18, which are not visible. So the greatest common factor, the highest number that we all have in common, is the number 6, and I would circle them and identify them as the largest number that they have in common is 6, so I can pick my best answer. You could also do process of elimination, that you see the number 12, but 18 is not divisible by 12. 3 is a common factor, but it's not the greatest. It's just common factor. And 2 is just a common factor, but not the greatest. You want to make sure that you have the greatest common factor in order to pick the best answer.